My name is Michael Amstelveen, and I'm a system engineer working at Arista. I have an EMEA role, and I cover the Netherlands and some part of the EMEA. We've got Sjaak, who's a sales rep in the Netherlands. Today I want to talk about the integration we have with OpenStack. Lots of excitement about OpenStack. We were here like 3 years ago or 2 years ago, where everybody like, what is it and should we? But now you can definitely see people moving, ahead and really doing some deployment with OpenStack. We've got some customer references if you guys are interested. So OpenStack on top of Arista is working, and it's sort of running in production. Quickly on what it is that we do, because some people might not be aware of what we're doing. We're a switching vendor, right? We build data center switches. We've got our volume products versus value products. Volume is generic data center deployment, and value is more like the HPCs, the high performance computers, high frequency trading for low latency, and so on, right? One of our unique selling points is that we've got a single operating system. So you go to our website and you can download a single EOS image, which runs on the smallest switch, which is 24 ports by 10 gig, one / 10 gig, and it runs on the biggest box, which have more than 400 gig interface in it, right? So pretty cool. Besides hardware, we also make software. We're spending quite some time on software as well. And basically within Arista we have something called Cloud Vision. And Cloud Vision is a framework of CVP and CVX. CVP stands for Cloud Vision Portal, which is a turnkey solution for customers who basically don't want to, do the manual CLI configuration. Cloud Vision Portal basically does the automation for you, right? The configuration management, change management, and then we integrate with companies like ServiceNow to approve configuration changes. We archive the configurations for you. Telemetry, whereby you can basically find out real time what is going on in your network, and so on and so on. Today we're going to focus on Cloud Vision Exchange, which is a sort of abstraction layer we've created towards node-bound APIs. You can imagine that we're partnering with a lot of controllers like OpenStack. Now, it wouldn't be fair for us, for the community, if we develop something on our switches and then OpenStack basically need to go and configure something like an MLAG, right? They have no idea what an MLAG is. So we created an abstraction layer to hide this sort of information, right? And this abstraction layer is like a single touch point, and it carries all the information which is required for the controllers to talk to. The other reason for CVX is just scale. So traditionally you would need in an OpenStack, or if you're working with controller, it would require the controller to talk to all your switches in the network. Now, having said this, you might run into scaling issues, performance issue, right? Because a single MAC change, for example, which needs to be propagated, is going to have a churn on, or might have a churn on your control plane of your network or your controller. So, having said that, this might work if you have like a handful of switches, but if you're going to start to have tens of switches or hundreds of plus switches, then Cloud Vision is definitely something we would recommend you to have in place. So basically what we do is we talk OVS DB or an API towards the controller, and then we basically serial stream the data towards the switches. Any question on this of the concept, right? The sort of middleware. It's not a controller. It's just a single touch point, a marketplace of information, basically. So this CVX has visibility of your physical infrastructure, right? So we have a lot of customers doing cool things because it has all this information, right? Make sense? Cool. Quite often we got the question like, okay, cool, why all this integration, right? Why do we bother about integration with OpenStack? And I think that the reason is pretty straightforward, is that it's all about automation nowadays, right? You don't want to manually, I'm still surprised talking to lots of, customers or prospect, these guys are still configuring the VLANs on switches, you know, on a manual basis. And I'm like, really? 2016, you're doing this manually? So why this integration, right? Basically, what we want to do is we want to take away this day-by-day tasks from you guys, right? And let you guys spend on cool things in the network instead of configuring a VLAN. So that's the first thing. The second thing is visibility. Now, quite often in a network, right, it's running, and if it's running, it's cool, it's fine. But once you need to troubleshoot stuff, quite often you don't have the visibility you need as a network administrator. So basically what you guys will find out hopefully is that we're going to provide you the visibility and show you guys what is basically running in your overlay, right? So with OpenStack, you're going to find out which VM, which tenant, which network is behind which port. Right? So that's basically the driver of the integration. Anyone familiar with Neutron, ML2? Yeah, cool. Anyone not familiar with ML2? Okay. So the ML2 is a plugin which basically is the bridge between OpenStack and our switches. So we'll find out later on in the following slide that if you provision something in Horizon, either you do it through Horizon or you do it to an API, we're going to call the ML2 plugin to talk to our Arista switches. So you'll find out that multiple vendors have their own ML2 plugin, which is available on GitHub or you know some branches of other companies like Canonical or Mirantis. So this is just a plugin, right? And this is Arista specific plugin. So the way it works, and I apologize for this because it's really hard to read. But basically what you have is that you have your OpenStack deployment, and then you've installed your Arista ML2 plugin, and then let's say I'm going to create a network. This network now will do an API call to CVX, Cloud Vision Exchange, which then will provision the network, right? It will create a network, and then from then on, let's say I'm going to create a new network. You assign an IP address, and a VLAN is automatically created, and then this network is created, and then it's basically available. So, hence and this is the only way how you can, you know, if you have a multi-vendor environment, you have another ML2 plugin in order to talk to other switches as well, right? So does it make sort of sense? Okay. So the idea is as I've mentioned, right? It's all about automation. You go there and you deploy your network once, and you can do this fully automated using open source ZTP zero-touch provisioning servers to bootstrap your switches automatically, so that you no longer need to console into the switch, and this can be sort of save you a lot of time. Zero-touch replacement, switch is broken, or there's something you need to replace, right? Just pull off the cables and replace with another switch, and we're going to take care that, you know, your switch will get the latest config as per the ZTP server. So, and then you've configured your ML2 configuration, and you specify that you're going to use some Arista switches in there. And from then on, you can basically start spin up your networks, create VLANs or create VMs, add VMs to networks, and so on, right? So let's have a look on the different options we have. We have like the sort of traditional VLAN-based networks where you have a leaf spine architecture, and then this is a pure layer 2 environment, right? Where we're even using MLAG on the spine switches, and then you basically spin up a VM, create a network, and this is just pure a layer 2 network. You eliminate the use for spanning tree because you're using something called MLAG, which basically acts as a logical switch. How does it look like on the, as I've mentioned initially, right? One of the things we're trying to help you guys with is visibility. So once we've created a network, I can now go on my switch and find out that VLAN 502 was dynamically created through the ML2 plugin, through CVX, to our Arista switches, right? So I haven't done anything on the switch other than, you know, maybe just an IP address and configured connection to ZTP. And I've done this either through my console or through ZTP, right? Zero touch provisioning. One of the things which is required here is to make a correlation between your servers, to find out where your servers are, where the VMs are, and to allocate the VLANs is that we need to run something called LLDP, right? So this is the discovery protocol which talk between your servers and your switch. And in that case, now we know that the OpenStack host is behind Ethernet port 3. And this is the neighbor port of this OpenStack host, right? So again, from CVX, you do a show OpenStack VMs. It's going to tell you that we've created a VM called OSINS1. We've assigned it to net 1, and it is behind host 4, right? So right now, right, I don't. If you have OpenStack running, I cannot see how you have the visibility as a network admin to find out where your hosts are running, right? And that's why customers really like and appreciate what we're doing here, is that we give the network guys the visibility, as in, you know, guys, this is where where your VMs are running. It also tells you which VLAN is assigned, right? Quite often you end up in a discussion like, I've told the server guys, hey, you should use VLAN 500, and then they go and configure VLAN 502, for example, right? So there's a mismatch of configuration. This will basically tell you pretty quick that, you know, there's a mismatch in your VLAN configuration. Right.
This is running on the CVX.
Right.
So I'm checking this from CloudVision. CloudVision has the state.
Yeah, so CVX is nothing else than EOS, our operating system, called EOS. And this is what you run in a VM. And then this gives you the visibility, as in, this is what is, remember CVX is the middleware? Yeah. So there's nothing else than EOS, our operating system, running in a VM with some special processes and services running. Right. What else do we have, right? So we're seeing more and more customers moving away from these layer 2 networks, and they're looking into layer 3 networks because they want to run out of, they don't want to use spanning tree or rely on layer 2 anymore, and maybe it doesn't scale layer 2, right? So what we can do is that we can build a layer 3 fabric where you run either BGP or OSPF or ISAS between your spine switches and your leaf switches, right? Now you don't need to run any underlying eBGP or IGP. You can run eBGP point-to-point directly, right? Now there are also some customers, specific customers, I would say, right, where they prefer to run layer 3 up to the server, if you like, right? Right now I'm still trying to understand what the benefits are of running layer 3 up to your servers, but if you want to, you could do so as well, right? So you guys got the concept of VXLAN, I assume, right? This is just an overlay protocol where you can tunnel layer 2 over layer 3, right? Now, again, once you are using or introducing VXLAN, you're going to run into a couple of new things. One of the things is called a VNI, Virtual Network Identifier. And this is basically the identifier which is going to be used in your fabric, right? So from these top of rack switches, the VTAPs, virtual tunnel endpoints, downwards, you talk VLAN. And then between the VTAPs and your spine switches, right, you're gonna see the VNI, the Virtual Network Identifier. So packet comes in, it gets encapsulated. You strip the VLAN, the customer VLAN, and you encapsulate your packet into a VNI, a UDP header, and you add the VNI in there. So this mapping is something we also do automatically, right? So in here you could see that I've got a layer 3 fabric, and then on CVX it will tell you that we've created mapping dynamically. We've assigned a VLAN to it, and we now do the mapping automatically between VLAN 502 and VNI 100,502, right? On the other side, the opposite is going to happen, right? So packet comes in on this VTAP with VNI 1,502, and we're going to strip the VNI and we're going to push the VLAN 502 towards the host. Any questions with regards to the VLAN and VXLAN design? So the other challenge you will or you might have if you're deploying a VXLAN environment is that you have like two options, right? One of the options is to run all your VTAPs in hardware on an Arista or any vendor switch which supports VXLAN, or you have the ability to push this functionality down to the hypervisor, right? Now nowadays there are a lot of network interface cards which have this offloading for your VXLAN packets. So in case you want to run your VTAPs on software on the hypervisor itself, you're gonna end up in a situation where you have your compute nodes virtualized, fully virtualized, but you're gonna still end up with your storage cluster or your bare metal servers which are not virtualized, right? So in this case, let's say you wanna, you need to create a bridge between your bare metal and your compute nodes, right? So what we can do here is that we can, again, it's all about automation. It's all about keeping you guys make life easy for you guys. So basically, what we do here is that we have the ability to talk to a neutron, so to speak. That neutron will know that these guys exist. Once a new VM comes up, neutron will learn about this new MAC address, and neutron will then on its terms say, hey, I know that MAC address of this host is behind this VTAP, so in that case if this bare metal server or storage device needs to communicate to any of the hosts, it knows behind which VTAP it is, right? Make sense? Any questions on?
Yeah, at which layer is that done? Layer 3 or is it?
This is
or a specific protocol?
no. So we use OVSDB, right, between the between Neutron and CVX. So anytime a new VM comes up, it's going to advertise the MAC address towards Neutron, and then Neutron will on turn tell us, because we have this ML2 integration, hey, I've learned a new MAC address, and by the way, it's behind this new VTAP. And I can see that, this guy is in the same VLAN. I'm going to provision the VLAN on this port, and I'm going to push this MAC address into the MAC address table so that you can have end-to-end reachability. Now this is all sort of layer 2, and then the other thing we have is the layer 3 plugin. At some point you might want to route between tenants or between VMs. Now in this case what we basically can do is that once you go in OpenStack and you create a network or you create a gateway, Neutron will then configure an SVI, so a layer 3 IP address, within the VLAN in order to give you, reachability outside of your own tenant. So again, I haven't, so far we've done a couple of things, right? And I haven't touched the switch CLI at all. This has all been done automatically, including the visibility it gives you to find out which VM and which network is behind which port, right? And then one of the things we started to do as well is the support for hierarchical port binding. So previously, if you would build a network like this, and you would use VLAN, let's say VLAN 100, this VLAN would have a global meaning. In the sense that if you create VLAN 100 on this trunk port, because this VM is in VLAN 100, you could not use VLAN 100 and on any other Tor switch for a different tenant, right? Now with the concept of the hierarchical port binding, you can now basically create VLAN 100 for tenant 1 on this Tor switch, and you can do the same thing, have another tenant 1 on or a different tenant on a different Tor switch and reuse the VLAN 100. Now the reason for this is skill, right? So if you have, with the traditional, without port binding, you have this traditional way of doing things, which means that you can only have 4,000 VLAN within this networks, right? Now we have customers which might want to go behind the 4K VLAN, and this is where hierarchical port binding will come to play. The other thing we do with the layer 2 gateway basically is that we also have the ability to add security. Well, to basically, if you create a security group within OpenStack, this will get applied to your hypervisors. But so far, nobody basically was able to add or apply the securities to your network, right? So what we can do nowadays is that we can also sort of intercept this security group on OpenStack and then apply the same security which is applied on your hypervisor, apply it with ACLs on the Arista physical switch.
And that's only done by one command, by creating the security group as an operator. It will automatically be configured both on...
Exactly. Meaning that, assuming that you have this VLAN, the network exists on this, obviously, right? Yeah.
And of course, that only works in a layer 3 fabric.
No, it could work on, well, yeah, it is, it's a layer 3, ACL.
So it should be a rooted network, then it works.
It should be?
Rooted. Layer 3 network.
Yeah, so assuming indeed assuming that you've terminated layer 3 on your top of rack, then indeed it's a layer 3 ACL. Okay. That's right. Yeah. Any questions regarding? Because I think this is basically it's in a nutshell, and I can show you the configuration and all these kind of things, but I only had like 30 minutes. I don't want to rush through things, but I had a feeling that I did sort of. But hopefully you guys get at least a little bit of an understanding what Arista is doing, and again why we believe and why our customers sort of appreciate the work we're doing. Obviously we're definitely in within the OpenStack community, right? We've got some key developers who participate in developing the OpenStack and so on, right? Any questions with regards to our integration, our products, support, suggestions?
Yeah, not technical, more like since when does this exist, this integration level?
Yes. Oh yeah. So
how long is it there? Is it new? Was it 3 years ago?
No. So hierarchical port binding I believe was introduced last year, somewhat within the OpenStack community. But I sort of like your question, because quite often you go to sessions and then people are presenting fancy slides and so on, and then you go home and then you get disappointed because this stuff is not being there, right? Or it's on the roadmap and so on.
I was wondering
Yeah.
how many of the customers are using it today. That's
Yeah.
my next question. You're getting it right.
Yeah. So guys, this is all available and all running in production, right? I'm not going to talk about customers. Well, I'm not allowed to talk about the customers using these stuff, but this is in production and it is available.
Okay.
Right.
Great, thank you. Do you need additional licensing to use Cloud Vision? CVX?
Do you need additional license to use Cloud Vision? Cloud Vision on its own, so we have 2 licenses, so to speak. We've got a Cloud Vision license as in one, which is definitely a license, because it gives you the ability to do some automation, right? Telemetry, real-time streaming of error counters or packets or interface status, temperatures and so on. But we also have a light version of Cloud Vision. So a Cloud Vision Lite is basically the CVX where let's say you want to use your own DevOps tools, Ansible, Chef, and Puppet on the Arista switches to provision your network. You're more than happy to do so, but then you're gonna need something called CVX Lite or Cloud Vision Lite for the integration. Does it answer your question?
Yeah.
So this is, I'm talking about DevOps tool, right? I mean, this is just one way of doing things, right? We have lots of customers who, were more than happy to use their own skills, in-house, tools, develop tools. Ultimately, this is just a Linux box, right? I mean, it's a Linux server with a lot of 10, 40, 50, 100 gig ports. Nowadays, even supporting 25 gigs. I don't know if you guys are aware of the 25 gig Ethernet standard. But make sure you sort of pay attention to this if you're going to do any investment on your hardware, and make sure that they support it, because 25 gig is definitely something you want to look into. Final questions, suggestions, feedback? Useful, not useful? Should we do something else?
Useful.
Okay, cool. Well, thanks a lot for your time, Dylan, and have a good weekend. Thank you, guys.